Hello everyone, I am Siddharthan. In this video, let's host a Llama 3 model on local using Ollama, and using this LLM, we are going to perform retrieval augmented generation, shortly known as RAG. So RAG is basically when you want your LLM to answer from a context window. So let's say that you have a document and you want the LLM to answer based on the content that's present in this document instead of the large corpus of data it has been trained on. So this is what RAG means, and in this video we are going to do all this locally by using Ollama, using which we will pull our Llama 3 model and we will host it in our local system. So this will be the agenda for today's video, and let's get started. So the first step is to pull the Llama 3 model. So for that, first you need to install Ollama. So I've already made a video on how to get started with this Ollama thing. You can go through that video if you want. I'll give the link of that video in this video description. You can check that out. So next, once you're done with that, go to Google and search Ollama Llama 3. So if you want to download, you can just download from this page as well. So the download process is pretty simple for Mac, Windows as well as Linux. So it's like not tough at all. So once we are done with the installation, now we can pull the model. So here you can find the different models that's present over here. So you can search the models like Gemma, Llama 3 and so on. So our model of interest is Llama 3, and even if you want to use a Gemma, let's say that you have a machine that doesn't have like that large of a GPU. So for example, my local machine only has like a 4 gigabytes GPU because it's a NVIDIA GTX 1650 Ti. So it only comes with 4 GB of GPU RAM. So here I'm currently using a EC2 instance with 16 GB GPU, which is a T4 Tensor Core Tesla GPU. So again, hence I'm using a Llama 3 model. So if not, you can just use a Gemma model as well. So that's the main thing. So let's say that we have searched Llama 3 in Ollama, and you have this different version. So you have 70 billion version. You can also see the size over here. It's 40 GB, and the 8 billion version is 4.7 GB, and you can also see it's Q4, which is 4-bit quantization. So the weight or the parameters of the model are reduced to a precision of 4 bits. So the purpose of doing this is your model's size decreases, but the performance or the efficiency doesn't like affect so much. So of course there will be a drop in the performance, but it's not like that much. So that's about quantization. So for RAG, we can use instruct version instead of the base version. So I'll click this instruct, and in order to pull this instruct version, you have to use this particular command. So this is Ollama run. So this is used when you have already pulled a model, and then let's say you want to run this model, so you would use that. So for the first step, you need to pull it. So I'll come to my terminal, and if you're in Windows, you probably would have installed this Ollama, and after that you can access this from the terminal from your Windows PowerShell. So Linux and Mac users also can access this from the terminal. You can say Ollama space help. So this will display like all the commands that you have over here. So serve, create, show, run, pull, and so on. So let's say that I can just type in Ollama list, and this will list all the models that I have pulled already. So here you can see that I have Gemma 7 billion model, Llama 3 instruct this particular model. So let's say that I want to pull just the base version 8 billion. So what I should do is I should come to the terminal and say Ollama pull. So look at the name over here, which is Llama 3 colon 8 billion. So Llama 3 colon 8 billion. So when I run this, so it's going to load the model. So it's going to pull the model from the repository. So that's the first step. But again, we are not going to work with 8 billion. So we are going to work with 8 billion instruct, right? So I'll clear all this and list this again. So now I have 8 billion instruct and Gemma 7B. So this is how you can pull the model. If you want, you can use again Gemma as well. So Gemma comes with 7 billion version and 2 billion version. So you can check that out as well. So that's the other thing. Okay. So now we can go into the coding aspects where we will load this model and how to do the retrieval augmented generation by passing a document and asking a question to the LLM. So that will be the next step. So for this you need a bunch of libraries. So we are going to install LangChain and LangChain community. So the versions are given over here. So I'll share you this particular notebook, and then we have this FAISS, which stands for Facebook AI Similarity Search. So this was developed by Facebook's AI research team. So this is just to find like a similarity search of the vectors. So here we will convert all the content of the document into vector embeddings, and the query will also be converted into vector embeddings, and we do a similarity search. So for that we need this. And FAISS comes in two versions. One is CPU and the other one is GPU. And because of some CUDA version errors, so GPU is giving me some issues, so I'm going with CPU. And even if you are in Python 3.10, you probably shouldn't be facing any issues, but if you are in 3.12, so sometimes like it's causing issues with the CUDA errors and so on, so you can figure that out maybe, but if not, you can just use the CPU version for now. So we have this FAISS CPU, and then we have the unstructured. So this unstructured library is used to load the content of the PDF file, and then we have this PDF, related code for this unstructured. So that comes with this unstructured square bracket PDF. So that module will be downloaded, and then you have transformers. So we are downloading the transformers and the sentence transformer. So this is used to load the embedding model. So we have the sentence embedding models. So in order to load that, we are going to use the transformers and sentence transformer library. So these are all the dependencies that we need. So the next step is, once you have installed all this libraries, I've already installed, so I've commented it. So if not, if you haven't already installed it, you can uncomment this and work on it. So the next step will be importing the dependencies. So here I'll say importing the dependencies. So I'll say import OS. I'll tell you why we need all these things. Or the next thing is import langchain underscore community dot LLMs, import Ollama, and from langchain dot document underscore loaders, import unstructured file loader. From langchain dot embeddings, I'll explain you the purpose of all these libraries and functions in a minute. Once I'm done with this, FAISS, so all should be uppercase. From langchain dot text splitter, import character text splitter. And finally, we need langchain dot chains, import retrieval QA. Okay, so these are the things. Let's understand this. So OS we need, one second, this should be from so OS is used in order to access some of the files that's present in our system. So for that we use this, and then we have this Ollama is used in order to access the model that we have just now pulled, which is Llama 3 or Kema model and so on. And then we have this unstructured file loader in order to load our PDF file, and then we have this langchain dot embeddings. So from langchain dot embeddings we are importing FAISS. So okay, so this should be not embeddings, but okay, let me try this again. From langchain community dot vector stores, import FAISS. So from langchain dot embeddings we have to load the Hugging Face embeddings. These are the things. Let's run this and see if this is working. Okay, so it's worked well. So we have Ollama in order to access the LLM that we have just now pulled, and we need this unstructured file loader in order to read the PDF file and get all the text content out of it. And then we have this FAISS for similarity search of vector embeddings. And then you have this LangChain.embeddings. We are importing this Hugging Face embeddings using which we will convert the text into vector embeddings. So the next step is character text splitter. So this is used in order to chunk the content that we have in the PDF file. So we cannot pass this entire text. So instead we would chunk this in a bit by bit fashion. So once all these chunks are present, we will encode those things into a vector embedding thing and store it in a vector DB, or just create a knowledge base out of it, and later we can use FASS in order to do a similarity search. So for chunking it, we are using this character text splitter. And then we have retrieval QA. So there are like different chains. So there are like conversational chains, retrieval QA chains, and so on. So our focus here is just document question answering. So for that, we can just stick with retrieval QA, where you can just pass this document thing and pass a question and then get a response out of it. So this is how all the things work. So if you are also not very sure about the concept of retrieval augmented generation, I've already made a video about that. So it's like a conceptual video of all the things that's come together and the architecture of it. So I'll give that video link in the description as well, so you can check that out. So that's all about the import statement. Now let's load the LLM. So I'll say LLM is equal to Ollama, and within that I can say, so LLM is equal to Ollama, model is equal to, so we have to name this model. So the model name is Llama 3 colon instruct. So this is the 8 billion version. The other version is 70 billion. So Llama 3 instruct. And the other thing that I'm going to need is parameters like temperature. So you can also include other parameters as well. So temperature is kind of determines the randomness of the response of the model. So when I run this will load the Llama 3 instruct model. So this won't work if you haven't pulled your model already. So this will work only for the list of models that you have pulled and it's like available to you. So here also you can see the sizes of the model. So that's the next step. So we have loaded our Llama 3 instruct. Again, if you're working with Gemma, right, so you just have to replace this Llama 3 instruct with whatever Gemma version that you're working on. So 2 billion just comes with Gemma colon 2 billion. So you can check that out once and you can load that. So the next step is loading the document. So here I'll put a comment saying that, sorry, so loading the LLM, which is Llama 3 in this case. The next step is loading the document. So for this, I can create a variable called as loader, and loader is equal to unstructured file loader, which is the function that we have imported. And within that, we can pass the name of the file. So for this, we are going to work with the PDF file, and that PDF file is the paper that was released on transformers. So I'll copy the name of this file and paste it over here. So both this notebook and this file are in the same directory. So I'm not giving any path to this. I'm just mentioning the name of this file, and I can say documents is equal to loader.load. So this will load the content of the PDF in a document data type, which is an unstructured data type. Let's run this. So this will load this constraint. So this may take some time depending upon the size of the PDF. So if you want to know how big of this PDF file is, right, maybe I can open it and show it to you. So in the downloads, oh sorry, this is the PDF file. So you can see the total number of pages is 11, and it has like some content about like the transformer architecture. So this is the paper that was released by Google first, basically on the transformer model. So we have this documents is equal to loaded.load. So this will load the documents, and the next step is we are going to create chunks for this document. Create document chunks. So I'll say text splitter is equal to character text splitter, and we can mention like what kind of separator needs to be. So let's say that the separator is /n, which is a new line separator, and then we have this chunk size, and chunk size, let's say that it's 1000. You can play around with the different numbers, and overlap is equal to 200. Right, so here we are creating an instance of this character text splitter and giving the parameters for this. The separator can be new line, the chunk size can be 1000, and the overlap is equal to 200. So wherever it sees a new line character, it's going to separate those into different chunks. And again, the maximum number of characters that can be present in one chunk is 1000. So that's what we are mentioning over here, and the overlap is 200. So that means we won't chunk it just by the character sizes. So what happens is when you kind of chunk it like in a discrete way, the LLM or the vector embeddings may not have this proper context. So maybe I'll show this to you visually. So let's say that we have this a large paragraph about this transformer thing, or let's say we have this paragraph, right? And when we chunk it, let's say that let's take this example. So these lines are chunked to one chunk, and the line after that are chunked to a different chunk. So we don't do that. So instead we will first make this as the first chunk and do a overlap. So let's say that this has like, let's say 6-7 lines, and the second chunk will start from this line. So there will be a overlap so that the context is not lost when we do this conversion from vector embeddings, text to vector embeddings. So that's the reason we are mentioning this overlap parameter of 200. Again, you can play around with this number. So this is the instance that we are getting. Okay, so this should be chunk overlap. So we are instantiating this character text splitter with all these parameters. Now we can pass our documents, which is basically the content that the unstructured file loader has loaded. So here I can say, you can print and show this to you. So you can see, so this is the entire text that has been derived from the PDF using this unstructured file loader thing, and it's in the type of document thing, page content, all this entire content. So I'll delete this for now. So here we can say text chunks is equal to text splitter dot split documents. So this is in documents format, so we can use split documents. Sometimes you can also chunk this as just as text string data types. So in those cases you will use split text. So here we are saying split documents, and within that we can pass the documents variable that we have created over here. So let's run this. So this step is done. So first we have loaded the document using unstructured file loader, and then we are splitting this documents content into different chunks. So the next step is loading the embedding model. So here I'll say loading the vector embedding model. So this is used to convert this text into vector embeddings. So let's create a variable called as embeddings is equal to Hugging Face embeddings. So within this Hugging Face embeddings, you can use specific models that's present in the Hugging Face library, the Hugging Face library or Hugging Face hub, but you can just go with the default one by just mentioning Hugging Face embeddings. So let's run this. So similar to loading the LLM, this will load the embedding model. There are some warnings, but you can ignore that for now. So it's about like resuming the download. So the next step is converting all this text content into vector embeddings using this embeddings model. So here I'll say knowledge base. So knowledge base is equal to FAISS dot from documents text chunks comma embeddings. So we are going to convert all these text chunks into vector embeddings, and later this will be used for similarity search from this FAISS, the similarity search library. So this will be the next step. So we are almost done with this. So only like there are few things left over here. So now I'll say retrieval QA chain. So let's say that QA chain is equal to retrieval QA, the chain that we have imported, dot from chain type, and here I'll say LLM comma retriever is equal to knowledge base dot as retriever. Hmm. Okay, so we are creating a QA chain, a question answering chain. Okay, knowledge base must have made nearer. Okay, let's rename this and run this again. We are creating a variable called as QA chain and using this retrieval QA, which is used for this question answering task coupled with this, vector DB and LLMs. And from chain type, we are passing a LLM and the retriever. Retriever is basically your knowledge base as retriever. So what basically happens in this RAG thing is, right? So you have a document. So in this case, the attention is all you need. Paper is the document, right? This entire content will be read and this will be stored in a vector database. So if you want to use an actual database, you can go with ChromaDB, LansDB and other vector DBs that are present. This FASS just runs in the memory. So let's say that we are considering a vector database which store these vector embeddings. So all these contents will be converted into vector embeddings and stored in the vector DB. And for each of this text, let's say that a particular sentence has been converted into a vector embedding. So it's nothing but some set of numbers that represent this text as vectors. And there will be this corresponding IDs as well to extract this corresponding text from those vectors. So now you have a vector DB that has the vector embeddings of this entire document. And now the user asks a question. So let's say that the user asks a question about this hardware and schedule. So now what happens is you would convert that query as well into a vector embedding, and now you search the vectors that's similar to this question to this entire vectors of this document. So let's say that in this case, right, so when the user asks something about, let's say, the machine translation thing, so the question is about machine translation, so it will convert that into a vector and search that vector with this entire documents vector embeddings, and let's say that it will extract this particular text. So now you have the question and the content in which the answer may be present. So now you send this question in text format as well as the answer in text format to the LLM, and the LLM will frame the answer. So this is all that's happening. It's not like the LLM kind of feeds from the vector embedding. So it doesn't kind of freeze the vector embeddings. So what happens is the vector embeddings is used in order to do the similarity search and find the similar vectors. Only the question and the relevant content that has been retrieved from the vector database is sent to the model. So it's basically like the question will be, what is machine translation mentioned in this paper? So that question and this particular text will be sent to the model, and the model or the LLM in this case will the Llama 3 model will frame the answer for this question and it will send this to us. So this is what happens. It's not like the entire content is fed to the LLM. So that's not how this works. So this is about the architecture of this RAG, and this is what I've explained in my conceptual video as well. You can check that out if like you want to understand like this concept like more clearly. So this is about this QA chain. Next, let's ask a question. So let's say that this question is equal to, let's ask a simple question of what is this document about, and then you have to say response is equal to QA underscore chain, the retrieval QA chain that we have created, dot invoke. So you have to use this invoke, and within this you can pass this query as a dictionary. Query colon question. Now let's print this response. The final answer will be present within this response and within the key called as result. So you can check that. Okay, so let's run this. So here we are creating a QA chain and passing the LLM and the knowledge base, the vector embeddings that stored, and then we are passing a question. So this question will be converted into a vector embedding, and we will retrieve the relevant information and then pass this to LLM. So this is what happens in a QA chain, and we are using this QA chain.invoke to invoke this chain which has this LLM and the knowledge base, put this query and get the relevant response from this. So this is how this RAG for this retrieval QA works. And let's see. So the LLM of choice in this case is, we know that it's Llama 3, but again, as I said, you can use Gemma, or if you want to use GPT-4o, right? Even you can use the LangChain version of this GPT-4o. So you can access GPT-4o API from LangChain itself. So that API thing you can pass to this LLM and then pass this in turn to this retrieval QA chain. So this answer says that this document appears to be a research paper or article about the transformer as sequence transaction model and so on. So it was able to capture that information properly. Maybe let's ask another question of, again, a similar question of what is the architecture discussed in this model. Let's ask this. So this, the second turn kind of took about 4 or 5 seconds. It won't take like that much of a time. So the first time the model loads and all the other things happen, so it might take some time, but the later questions that you ask won't take that much of a time. Again, it also depends on the GPU that you are using. So the answer is the architecture discussed in the model is transformer and so on. Again, so we can't assure that all the questions that we ask kind of gives you accurate response, because this is fairly a smaller model. So Llama 3 8 billion version. So the larger version is 70 billion. Again, of course, we can't load it because of the GPU limitation. But if you are working in a company and they have that machine with them or the cloud instance with them, then you can use like the 70 billion version. But all this steps remains the same, so you can go to an EC2, instead of 8 billion you can kind of load the 70 billion version and so on. Again, if you're working on a local, if you have like let's say 8 GB GPU, you can load Llama 3 8 billion version itself, so it's only about 4.7 GB. But this is how this works. Let's just do a quick recap of what we have done. So the first step, we have imported all the dependencies that we need. So we have this Ollama in order to load the LLM, unstructured file loader to load the PDF file, FASS in order to do similarity search of the vectors, and then Hugging Face embeddings used in order to convert the text into vector embeddings. Character text splitter is used to chunk your PDF documents content into smaller chunks, and then retrieval QA where we will pass the LLM as well as the knowledge base, which is the vector embeddings that we have stored. Then we are loading the LLM from Ollama, the Llama 3 instruct model that we have pulled with some temperature parameter as 0, so that we don't want any larger randomness to the model. So, and then we are loading this using unstructured file loader, and then using text splitter, text chunks and so on. And then we are loading the embedding model, and we are converting this text documents into vector embeddings and storing this in this FASS thing for similarity search. And finally, we have this retrieval QA chain passing the LLM and the knowledge base to it. And then we can ask this question by using QA chain.invoke. So I hope everyone is clear about this, and please try and see how this code works. So that is all from my side, and I'll see you in the next chapter. Thanks for watching.